I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, Assistant Professor in the Department of ECE. So this is the another session from this Analog and Digital Communication course. And in this session, we are going to take the questions which has been asked in GATE 2025, particularly the from this first two units, right? So let's see. So this is one of the very important course, analog and digital communications, where the questions definitely will come in the gate. So you should follow these contents, the syllabus, in order to solve these questions, right? So let's take the questions. This GATE 2024 is organized by your IC Bangalore only. So question is that an amplitude modulator has output in volts. ST is your amplitude modulated wave, that is A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. The carrier power normalized to 1 ohm resistor is 50 watts, right? So the ratio of the total sideband power to the total power is 1 by 9. So the value of B in volts is equal to how much, right? So first of all, in this question, what is given? Amplitude modulated wave is given. Here you can see the frequencies are 400 pi t, that is omega c, that is omega is equal to 400 pi, and then here omega is equal to 360 pi, here it is 440 pi, right? So if you will find the frequencies, then what will be the frequencies? Like omega is equal to twice pi f, then it will be cancel out twice pi, then it will becomes 200, 180 and 220. So it is very clear that the deviation is of 20 hertz, right? So here 200 is the carrier frequencies, and then plus minus 20 deviation, that is the message information. So this belongs to the carrier, and this belongs to the lower sideband, and this part belongs to the upper sideband, right? Now in this question, what is asking? A carrier power normalized is 1 ohm resistor is 50 watts. So carrier power is given. So carrier power means power you can calculate for any part, like amplitude a square by 2. So here a square by 2 is given 50 watt, and then a ratio of the total sideband power, right? So total sideband power means the lower power plus upper sideband power is, that is total sideband power to the total power. Total power means sideband power plus carrier power, right? So the a square by 2 plus b square by 2 plus b square by 2, that is entire power is the ratio of sideband power to total power is given 1 is to 9. Now, so question has been asked to find out the value of b, right? So how can we find? So first eta, that is useful power divided by total power. So useful power means sideband power, right? So sideband power divided by total power. Total power means carrier power plus sideband power, and that exactly we have to calculate. So in this manner, and the value is given 1 by 9. So we'll find out the PS, PC and PS, and then we'll put, and then we'll get the value of B. So it is given in terms of amplitude. So here m square by 2, that is sideband for this one, and PC, that is for this one, and another sideband power for this message information, right? So as per answer key, your answer should be in the range of 2.49 to 2.51. So let's see. So your in the question it has been given the modulated power, that is ST is equal to A cos 400 pi t and B cos 360 pi t and B cos 440 pi t. So if you convert this omega ct, then you will get the frequency message, right? So the first of all, the frequency is given, that is for 200, for this corresponding to this, right? So this is corresponding to the frequency, and then for message signal, this belongs to the message and this one belongs to the message. So this belongs to the lower sideband and this message belongs to the higher sideband. So you have the frequencies for lower sideband, that is 180 hertz, and for upper sideband your frequency is 220 hertz, right? So fc plus fc, this is fc and fc minus fm and fc plus fm. So your answer will be 2.5, right? So let's see the more detailed calculation. So actually, how can we find out the modulation that is the power? So here is some more detail. I just got these details from the Bipilati book only. Here you can see the advantage of the envelope detection in AM has its price, and the carrier does not carry the any information. That is why we are telling it the carrier is totally wasted, power wasted, right? So exactly how can we calculate the power? So here you can see PC we can calculate A square by 2 for this carrier, and P of S, that is this portion, we can calculate half of M square by M square T, right? So this is a way to calculate the power. So useful power means the mass, whatever the power contains by this masses. So that is PS, and total power means masses plus carrier. So this is a way, and with this way you can find out the eta, that is the maximum power utilized, right? So now let's find out in our case. So here st is already given, so now what to find? The carrier power. So carrier power we can find it here, the total carrier power v square by 2r, right? And so here it is given, that is a square, so a square by 2, so r is equal to 1, already it has been given in the question. And now let's find out the sideband power. So for the second and third part, right? So power for sideband, that is b square by 2 for this, and for the this one also b square by 2, so 2 into b square by 2, so total will have the b square for sideband power. Now put the values in this total sideband power divided by total power. So pt is equal to pc plus psb, that is the sideband power. And so now put the values here directly. You can put the sideband power, that is the b square, and divided by total power, that is b square plus a square, right? A square by 2 plus b square, and that equal to 1 by 9. Now further if you put, then b square divided by the 50, it has been given a square by t, a square by 2 is equal to 50, and then plus b square is equal to 1 by 9. So further solve, you will get the b is equal to 2.5 volt. So this is the final answer, that is v is equal to 2.5 volt, right? So as per answer key, it should fall in the range of 2.49 to 2.51. Okay, so that's all in this session. Thank you for joining the session. We'll come with some more questions which has asked in another gate year. Thank you.